Hey, this is Jody with WeldingTipsAndTricks.com. Today I'm putting together a big, heavy, 3/4 inch thick aluminum fixture using a strong hand tool BuildPro precision welding table. 6061 T6 aluminum water jet cut, and it's going to go together like cake because of all the fixturing and the tooling that's available with the table. So just to get a quick mock-up of it, I've got a dummy piece in the middle to get an idea how it's going to go together. And the center hub is not done yet, so I'm going to check out some settings on this thickness with that Iron Man 230 MIG welder spool gun. So what I've got here is a kind of a cross T-joint. It's got 4 joints on it. What I'm going to do is I'm going to weld them all 4, and I'm going to the first one is just cold, no preheat, and then that's going to serve as a preheat, and it's going to get a little hotter and hotter. Then I'm going to slice and dice, polish and etch, and see how each one penetrated. Also do a little vertical uphill welding. This is the first one. You can see it looks a little cold. It's spattering and sputtering, a little sooty. That's with the piece cold, no preheat. Definitely got a lot of soot and a little too much spatter. So the back side of that one, not changing anything, you can see is welding a whole lot better just because of the preheat. Still got a little soot problem. I'm tweaking my argon a little bit, but can't seem to get rid of all the soot. So basically what happens is they weld better and better until I get to the 4th one. You can see how this one just really hissing smooth, really a smooth arc. Preheat makes more difference probably than anything on something this thick in aluminum. So I'm going to want to sequence my welds on this fixture to where the thinner welds heat up near the thicker ones and so on, and also use a little preheat. And also I'm doing a little vertical up here weld in case I need to with multi-pass, second pass on here, because this is 3/4 inch thick aluminum and a single pass isn't always going to get it. Sometimes you're going to have to load it up pretty good like this. So next thing I'm going to slice it like bologna in the big horizontal bandsaw, and you can even kind of see where the welds are, just the way the weld metal cuts differently than the base metal. But I'm going to polish it with about an 80 grit flap disc here. I'm going to put a little wax on there to keep it from loading up and get a little smoother polish. The better you can polish aluminum, the better it will etch. And I'm swab etching here, and you know what I'm using? There's a lot of things like household products that will actually etch aluminum. A lot of alkaline cleaners, but in this case I'm using Drano. It's got a really high pH. You want to be careful using that stuff though. It's pretty nasty. You don't want to get it on you. And there's the aluminum uphill weld. Or you can also use a high alkaline cleaner like Purple Power, Purple Panther, several others, as long as they're high enough pH, will etch aluminum. But be careful with the stuff. But that's one way of checking for penetration, is polishing and etching. But you can't obviously do that on part because it's destructive testing. So now I'm going to measure here. I'm going to move the tape measure back and forth. So that's how you get the center of the measurement on something round. And I settle in on 36 5/16 here. And I want to know half of that because I'm going to scribe a circle with the Dremel points. So half of that's 18 5/32, and I set that with the Dremel points there. And I'm going to use a standard little hold down device that comes with the fixturing package with the BuildPro table. I'm going to use that for my center and just stick one of the points in that hole. I'm using a little makeshift layout fluid here, also known as black paint, but that'll wipe off easy with acetone later. And I'm going to get a scribe line of a circle so I'll know where I'm at. My machinist friend who I'm doing this job for made this dummy plug here. It's a spacer. It's also got a inside diameter there that the hub will fit on, and that sits down right on that head of that little deal. Gives me a nice center point to put the center hub, so it's at the right height, and I know I'm indexing off that hole. That's where I made my scribe line for my circle, and that's how I'm going to get this thing centered up, because the main thing about this fixture is that the hub is centered with the hole pattern that's going to be drilled in that outside flange. So just bumping it around, getting it, eyeballing it pretty close to that scribe line, then taking this center finder attachment with a long blade and running around it and tweaking it, eyeballing it, double checking it, making sure it's as close as possible. We can be a little bit off here because the center is going to be machined after the fact. It's going to warp and move a little bit as we weld it, but we want to be as close as possible. So now we're going to tack this little ring on here. With the spool gun, the settings aren't quite right here. I noticed when I was tacking this cold metal, I was getting an awful lot of spatter. So I tweaked that down a little bit before I started welding the actual welds. And now one more little adjustment, using that center finder with the long blade again. Now because I indexed off one of the holes, and because the spokes are indexed in line with one of the series of holes, I can then get this thing clocked right. All I've got to do is line it up with that line of holes. That's what's cool about having indexed holes on a precision table like this, is because not only does it help you eyeball stuff, but you can always get something clocked or square to 90 or whatever you need to do. And once I've got that right, I'm using these little quick clamps here. They just pop in the holes, and then they've got just enough clearance to where when you put pressure on them, they cock and bite, and you don't have to get a bolt underneath or anything. They just they lock down really quickly with one hand. So now that I got the hub clocked and locked down, it's time to tack the spokes in here. Now you notice the little notches all around on the outside. Like I said, those are water jet cut, and the guy that drew this up on CAD thought it would be a good idea just to put those little notches on there to keep from having to lay it out and index it, and so it'll just fit together like a puzzle. And he was right, because there's no real accuracy requirement for where these spokes go. I mean, they could be off probably a 1/4 inch and it wouldn't hurt anything, but it sure makes it easy not even having to make lines and fit it up. They just go where they go. So I'm just holding it with one hand. It's a pretty tight fit there, so I don't have to do a whole lot of anything other than line it up and prop the spool gun on there and get a tack. I'm just getting one tack to start with because I want to make sure everything's cool before I put more tacks. So with the ring tacked on and then these tacks on, I went ahead and got some more tacks here and there, and tack the other end of it where it goes around the large diameter flange. We're looking okay here. Now we've got to figure out the best sequence to make these welds, because I got to clamp this down. I can keep it clamped down flat, have it stay flat while it's clamped down this way, but all sides have got to be welded. So, I want to be able to weld the final welds with it clamped down flat again. So went ahead and welded some, flipped it over. When I flipped it over, I've got these little gaps here going on. But that actually worked out well because I don't want to put much weld on it. There's not a lot of strength requirement for this thing. It's mostly it's a line-up fixture for lining up a shaft inside a big part. And accuracy is important. It doesn't hold hardly any weight. So the more weld I put on it, the more I'm going to warp it. So I just want to get enough weld. In this case, I want to sink that weld in there because I got to grind it anyway, because I'm going to flip it back over and clamp it flat on the precision table. So I don't want much weld on it. I'm going to come back and sand those flat anyway. All right. Well, sidebar here. Sometimes you have to build things up. Things are miscut, whatever. You need to build it up, and using a big block of copper like this clamped to the bottom really helps. Really helps because it supports the weight, it supports the molten puddle and keeps it from sagging, and also traps your shielding gas. And it kind of molds it, kind of casts it like a mold, keeps it from hanging down very far, like I said. So sometimes you need to build things up, and this, I thought I was going to have to build one of these up, so I went ahead and did it while I was waiting on the hub. Turns out it didn't need it and had to grind it all back off, but figured I'd share it with you anyway, because that using that copper block is a really good tip. Works great for boat props. If you're building up a tip of a boat prop, clamping a piece of copper on it to cast the metal. Works good for bush hog blades or anything like that where you're doing build up. And You clamp that copper to one side and it supports it, holds the shielding gas. So never throw away your copper, just hold on to it, put it in your drawer, you'll need it one day. All right, well that is it for today. Thanks once again for watching, and visit weldingtipsandtricks.com.